Alrighty, we're going to get this show started. Good afternoon, guys. As a reminder, my name is Cash and I will be your host for day 2. And we are almost there, guys. This is the last session of day 2. We've had some really great energy and some great conversations. It is crazy how much time has flown by today. But as a reminder, if you guys haven't already heard these, please ask questions in the chat. We want to be challenged. We want to hear your beautiful voices. So do not hesitate asking any questions. And please take the polls. They are going to be at the bottom left of your screen. We want to get your input and learn more about what your experience has been so far at TechCon. And with that, we're going to hand it off to Anne, Dave, and Shane, who is going to be talking us through evolution of FIDO, passwordless, and digital credentials. So take it away, guys.
Thanks everyone for joining us today. My name is Shane Whedon and I'm a senior technical staff member in the Identity and Access Development team. With me today, I've got Anne Ho, who will also be presenting some of our content, and we have Dave Moore, who's on standby with us to help answer any of your questions as well. So without further ado, let's jump into today's agenda. Just to set the scene for you, we want to talk a little bit about what's led to the evolution of authentication on the internet over the course of time. And to do that, I want to draw your attention to this little chart in the top right here, which comes from IBM's Cost of a Data Breach report. For those who haven't seen this chart, the x-axis represents the percentage of times a particular blue dot on that chart was the initial attack vector for a data breach, and the y-axis represents the average cost of that data breach in millions of US dollars. So this is a magic quadrant you don't want to be in, right? And those dots in particular in the top right here are the ones that occur most frequently and are very expensive. And the types of technologies that we're talking about today address those particular initial attack vectors, and that's one of the reasons why this topic is really important. If we talk about this should be old news for most of the folks in this audience. If we talk about the problems with passwords, it really boils down to one thing, and that is human nature. So human nature is what leads to people using weak and reused passwords, and is really what these technologies that we're talking about today attempt to address. So a little bit about what we did about human nature in the early days of dealing with credential stuffing, and that was to introduce second factor authentication. And this is ubiquitous now, right? It should be pretty much everywhere you go. If you're on a site with password only authentication, and chances are it's a pretty low valued site. The way this algorithm kind of works is the user provides some form of first factor authentication. We make a decision about whether or not it's likely that you are who you say you are. Often that's done with techniques like trying to recognize if you're coming from a device that you've used before, or that you're accessing the system from a particular network, or that you're using the system in the same time of day. You might be using it in the past. We run this through some sort of risk engine, and we decide whether to increase the friction of your authentication experience by prompting for a second factor, or just to let you through. And this is everywhere. Some places the risk engine might be simply just always prompt for a second factor, and so you get a fairly high friction second factor authentication on every login. But more advanced risk engines allow you to reduce that friction by making determinations as to whether or not it's really necessary. So what does this threat address? Well, the main thing it addresses is credential stuffing, and credential stuffing is an attack where a bad actor takes a set of stolen credentials and then reuses them via typically a botnet across multiple other sites to try and find where you've reused your password. And those credentials, sometimes they might be socially engineered, but more often than not, they've just been stolen from another site. And like everyone else, you use a reused password or a variant of it. So what conditional MFA does not address here is phishing. And just recall phishing is an attack where an attacker stands up a site that looks exactly like, and sometimes proxies to your real site. Say from a visual point of view, it looks no different from your real site, except that it's not. It's in the control of the attacker, and they act as a man in the middle, and they present to you the exact same challenges that you see on your real site, and you provide them with the real answers, and then they have access to either the credentials themselves or more often the set of resulting browser cookies that comprise that site. So this particular type of attack made big news a couple of years ago when a service was used to particularly target C-suite executives of Fortune 500 companies and gain access to their corporate email. And once you own someone's email, you own a lot more of them and the things that they can do. So really, it has become imperative that high value websites offer means of authentication that address phishing, and that's where passkey technologies fit in. So passkeys are a new way of authenticating on the web that essentially bring public key technology, i.e. public-private keys, to humans in a human usable form. They don't rely on a symmetric credential like a password or even a time-based one-time password, which is also symmetric. They are necessarily different at every site, so a different key pair gets created for each site where you create one, so they can't be reused, and they're machine generated. The way that these credentials work is that they address phishing by way of the browser ensuring that you're connected to the site that you registered that passkey at, and you basically take that decision that a human had to make about, am I really connected to my real site, away from a human and make it a compute operation. Now, with every technology, there come new challenges, and with respect to passkeys, one of the things we've started to observe as passkey technology matures is that many providers, particularly the big platform providers and the password manager providers, like 1Password and LastPass and Dashlane and Bitwarden, those sort of guys, what they've done is they've started to allow their passkeys to be synchronized across devices. So, for example, in my Apple ecosystem, passkeys that I create on my Mac, I can use directly from my phone, and that allows me to have ready access to my passkeys no matter which device that I'm on. The effect of doing that is that passkeys, the security of that passkey becomes delegated from where I choose to store it as a website, to the third party that's managing that passkey for my users. So some providers are unsure how secure their users' passkeys are. This was true also for other credentials, by the way, including passwords. You don't know how securely your end users stored their passwords, but in the case of passwords, end users at least had a choice, right? They could decide to put them on a sticky note, or they could decide to use a password manager of their choosing. With passkeys, users have to essentially use a device to do that, and when that technology is a synchronized technology, such as a platform passkey, it's not always clear to the website if that passkey provider is offering a secure storage mechanism for the passkeys, and whether or not the attacker's attack vector just switches to the passkey provider themselves for that user. There's also one other challenge associated with passkeys that we've seen in the world today, and that's that simply there are some user interfaces where passkeys don't work yet. So certain web widgets, for example, that you might see thick applications pop up won't support passkeys yet, and clearly, command line clients struggle with passkeys as well, unless because they have to be re-engineered for it. So finally, the other concern that we see quite a lot with regards to offering, say, passkey only authentication on a site is, what do I do if my user loses their passkey? Today we see many different variations of forgot password flows. Most commonly, they are backed by proof of ownership of an email address, at least in the consumer space. But that same problem has to be solved for passkey-based authentication as well. Now, there is some relief here, because with regards to synchronized passkeys, so those that are synchronized across a cloud account by your passkey provider, like Apple or Google Password Manager or 1Password, or any of those synchronized passkey providers, provided the end user has the ability to re-access that account, they will be able to get access to their passkeys again. So that does in fact lend itself towards lessening the instances of account recovery flows, but ultimately you may have to fall back to whatever level of identity proofing that you performed when the account was created in the first place. And because the intention is that doesn't have to be done as often, then it's okay for that flow to be of higher friction. And sometimes you'll see, particularly in the consumer space, not so much in transactional business, but imagine you have a social site, for example, and you want to try to do account recovery. Sometimes it can be several days before you can regain access to that account. And they introduce that higher friction to make it less attractive for attackers to try to use the account recovery flow as a means of account takeover. So just to recap, this is a little comparison chart here on why passkeys solve problems that passwords have. All right, I went through these a little bit earlier. Passkeys are machine generated, they're asymmetric, they cannot be used across websites. They're not phishable because the browser ensures that you're connected to the same site via its trusted certificate list that you used when you registered the passkey, and that makes them impractical for remote attacks, unlike phishable credentials. So here's a quote for you. Any passkey is better than no passkey. That quote is mine. We use this quote a little bit internally here at IBM because we chose to offer passkeys for employee login, and there was a lot of discussion in our deployment as to whether or not we should restrict the types of passkeys that employees can use to log in as a first factor authentication mechanism, based on attestation or the proof of authenticator that user is using. And ultimately I landed on this phrase because the effect of saying you can only use certain types of passkeys here, i.e., for example, we can only use hardware bound physical security keys or something like that, is that you will exclude a large portion of your user base unless everyone is provisioned with that appropriate hardware. And as soon as you start doing that, then you have to have something else for those users to use. And that something else is going to be not a passkey, which means it's going to fall into the phishable category. So that is much worse in terms of looking at things on a security spectrum than just permitting a user to use any passkey provider as a first factor authentication mechanism, and then perhaps still applying conditional MFA if that's what floats your boat afterwards. So my advice is, if you're thinking about risks associated with using passkeys, and whether or not you should deploy them for end-user authentication in your environment. Remember this quote: any passkey is better than no passkey. Okay, so we're going to switch to a little demo now, and whilst I have a video recording of that demo, that's not my jam. So I'm going to change to a browser and give you a live demo here. This is my browser, and I've pre-populated it with a URL. This URL is to a Box document. It's actually to a Box document, which is the presentation that we're following today. And I'm on this browser unauthenticated. It's like I'm freshly logging in for the day. So Box is a third-party document storage provider, and it's one we happen to use here at IBM for document storage. When I visit this link, it's going to ask me if I'm part of IBM, which I am, and redirect me to my corporate IDP for login. So that's what's going to happen now. When I get to my corporate IDP, it knows that I authenticate to it with passkeys and immediately prompts me to use my passkey. And this is actually an Apple managed passkey. So I'm going to use Touch ID on my Mac to authenticate. And that's the entire user experience that I see. So conditional MFA is being applied now. It will recognize that I'm from a device that I've used before, and I'll be single signed on directly into Box, and you'll see today's presentation. So that single touch experience, the thing that we're all used to for opening our mobile phones and computers today, that fast, seamless experience is exactly what passkeys brings to users. And it's that experience, i.e. the delightful experience of fast, secure sign-in that will bring people to use it, not because it's actually more secure. Okay, some geeky stuff now. We'll look a little bit about the authentication, the architecture of passkeys in a little bit more detail, in case it's not a topic that you're particularly familiar with, right? So we all use browsers. We're familiar with that today, and we all use them to connect to websites. And in this particular case, we have websites that are protected with security products like our Verify SaaS product, which is what we used in that demo I just showed you for employee login, or our on-premises offering, Verify Identity Access. And it's these websites that include things like a FIDO server, which is the technology that passkeys uses in terms of standards. And the thing that is new is that instead of websites just serving up HTML pages which contain forms that prompt for things like usernames and passwords and time-based one-time passwords and confirmation screens for mobile push and stuff like that, it serves up pages that include client-side JavaScript that calls an API called WebAuthn. WebAuthn is an open standard produced out of the World Wide Web Consortium, and it's a JavaScript API for invoking the types of experiences like the login experience I showed you in that demonstration. And that login experience, depending on what browser and operating system you're on, launches a UI that allows you as the human to interact with a technology called an authenticator. And authenticators fall into a couple of different types or buckets. We call them platform authenticators and portable or roaming authenticators. And you saw me use a platform authenticator in my login, which was Apple iCloud Keychain. An example of another one might be Windows Hello, or can even be 1Password or Dashlane or Bitwarden or one of the other password managers with an appropriate browser plugin on a laptop or a credential provider that you've installed on your phone. In the other category of authenticators, we have portable or roaming authenticators, and the most common example of these are hardware security keys, such as a YubiKey, for example. And in our particular deployment for employees, we allow all of them, right? And then we use a a risk engine and conditional policy, very similar to what we see for conditional MFA that I showed at the start of my presentation, to differentiate based on what type of authenticator you've used and other risk factors to decide if we want to do additional authentication challenges, kick you out, or just let you in. So when it comes time to remembering which parts of this architecture are responsible for which components in a FIDO credential, remember that authenticators manage private keys for users. That might be on the device, or it might be in a cloud account in some sort of secure fabric. And servers store public keys associated with a user account. Compromise of one server and its authentication data does not provide an attacker with anything that allows them to authenticate at another site. And that's a key differentiation for the way things work compared to, say, any other symmetric key-based technology. Now, I'm going to provide a bunch of different resources here and tell you a little bit about them. Okay, so we'll start with what offerings we have in IBM for passkey-based authentication technology, at least those that are produced by our software team. We have a SaaS offering, which is our identity and access management platform called IBM Verify, or IBM Verify SaaS. And we have an on-premises offering, which has had about at least 15 different names in my 25 plus years at IBM, but is currently known as IBM Verify Identity Access. You might know it as TAM from the early days, or Tivoli Access Manager, or IBM Security Access Manager, which were two of the names it's had for long periods of time in the past. And I'm going to, if you're new to passkeys, I'm going to give you some resources here that will help you learn how to use them very quickly. And to do that, we're going to start with what's on offer in the SaaS world. So this first link here, ibm.biz/isv_fido_workshop, is a self-guided, hands-on tutorial that allows you to set up a trial tenant of IBM Verify SaaS and get passkeys authentication working. And I've run this workshop a number of times. I've run it in partnership with Yubico, where they've handed out YubiKeys and people have used them. You can also run it just with a platform authenticator like Windows Hello or Apple iCloud Keychain or a password manager. You can use any authenticator you like to run through that workshop, and you can get the basic thing running. Once you've got your trial tenant, you get the basic thing running in about 10 minutes. Okay, so if you really just wanted to dabble with getting a passkeys based system of your own up and running, do that workshop. Then I want to talk about another passkeys related technology that's available on SaaS that goes into a little bit more detail, and that's this flow called identifier first authentication here with passkeys. So identifier first authentication is a phrase coined to describe a login flow where the first thing you see on the login screen is a username field. And then you can put your username in there, and then what happens next is based on that username. But also in the username field, we can implement a thing called conditional mediation, which is another way of saying autofill for passkeys. And there are plenty of sites that do this today. And sometimes, if you click in a field, might be sometimes a credit card field, you'll get this opportunity to auto-complete it based on things that your browsers have remembered. Same with usernames and passwords, you'll get auto-complete offered. Well, passkeys has a very similar capability if you're using a platform passkey, and you can see a drop down in the username field that will allow you to just select your passkey there. This workflow, which is a add-on that you can add on to your existing IBM Verify SaaS tenant, brings that type of login experience to your tenant. And there's quite a lot of custom page templates and technology in that flow, which will enlighten you as to how to build a modern and very slick authentication experience for end users. I would highly encourage you to try that out. And just a little bit of a teaser here, I'm about to publish another one in the coming few weeks, and I can talk about this because it's not new product, it's just it'll be documentation and some assets for you to add on this flow to your tenant, which is called solicited passkey registration. And this can be hooked into your login flow such that if a user logged in not using a passkey, they can be automatically prompted to register one as part of the login flow, and then next time through they'll have a passkey to log in with instead. So this is a way of moving people towards passkeys by soliciting registration of one during their login experience. Now, that's probably enough to get you started with passkeys in the SaaS platform. If you're an on-premises customer of our Verify Access technology, many years ago now, like we're going back to the version of ISAM 907, we're now on version IBM Verify Identity Access 11. I wrote a series of articles that are still completely relevant on how to get started with passkeys. And back then, even the terminology passkeys was not prolific. It was just called FIDO 2. So use that series of articles. You can find them on my blog, ibm.biz/sweden, to become familiar with passkey technology in the Verify Identity Access on-premises platform. There's some very detailed information available there, and I'm always happy to engage with our customers on use cases that they need help figuring out. There's also some built-in scenarios in the on-premises platform that you can enable via wizards, and one of those is identifier first authentication, which helps you set up the exact same sort of flow that we have in the Verify SaaS link here on the left, and we also have inline solicited registration in that flow as well, which is the flow that I'm bringing to SaaS shortly. And then if you're a hands-on practitioner, like you support passkey authentication in your company or whatever, these are some tools that I have open sourced over the years, and a demo site that I run mostly for developers of passkey related technology, which I'm not going to go into in detail today, but suffice to say that in my work on passkeys, which has been very detailed since 2018, so over the course of the last 7 years, I've built these tools that help me solve passkey related questions, and they may be of use to you too. So feel free to go to my GitHub and have a browse around those repositories. And with that, I'm going to take a breath and hand over here, stop sharing, and hand over to Anne, who's going to take you through the rest of our presentation. If you have any questions, please drop them in the chat, and I will be on standby to answer them. Thank you, Anne.
Thank you, Shane. Let me share my screen real quick. All right. Did y'all guys see my screen okay?
Yeah, we can see it.
Perfect. All right. So thank you, Shane, for walking us through the journey so far. So now we're going to talk about verifiable credential. We're going to do a recap of the use case, and then we wrap it up. All right. Okay. So before we go through the verifiable credential, let's take a step back and walk back into the journey way back when, right? When we still have the centralized identity where each organization own their own the relationship with the end user, and just a single organization would be able to authenticate just that user, right? No sharing. And then because of that, then it come with too many credentials problem, right? Each of us potentially way back have many accounts and therefore vulnerable to different kind of attack. Then come federated identity, which provides us single sign-on capability. And through the established trust with different organizations, allow a single identity to be able to log into different applications and access different services, right? So it helped with the a little bit with the too many credential problem. And then of course the MFA and the passkey that Shane covered earlier certainly help make the authentication even more secure, right? But then we have the technology proliferation, right? And there's a change in the landscape where more and more users are start moving into the digital world and interact more on the internet, right? How do we address that? There come verifiable credentials. So it's an emerging technology that allow user to kind of own your own credential and be able to share a certain piece of data through point-to-point interaction. So then we might ask, what is verifiable credential, right? So let's take a step back and visit how do we interact today in our real world, right? All of us have some type of experience in where we go to the bank and we have to present certain like government type of ID to be able to access our account or even open account, or when you go to a gym where you have to provide some type of piece of paper to prove who you are so that you can gain access to the gym to do the workout. So how do we bring that similar experience into the digital world where you have to prove who you are on the internet, right? We need some type of digital credential to be able to do that, and these credentials have to be like issued from a trusted authority and be able to verify in a fast and secure manner online, right? Verifiable credential will provide a way for us to enhance the existing way of doing or proving identity in the real world and bring that into the digital world. And that's exactly what verifiable credential is. With that, what type of use case does verifiable credential unlock? So when we think about the experience that verifiable credential enhance or enable, we can see certain the following use case here. Number one is that we can simplify the user experience by modernizing like your existing piece of like physical identity, like your driver license, your membership card, even your employee badge, right? And any of that physical identification, to me, it can be transformed or digitized into a digital credential. So that's one use case. The second use case is, let's say we want to move into a user-centric interaction. Nowadays, we have a lot of concern in terms of privacy. Are we sharing too much information about ourselves online? So with the user-centric experience, we allow the user who own their own credential, hold the credential in their hand and be able to, well, not hand, but in their mobile wallet, for example, but be able to share certain piece of data that is needed for the type of transaction that they are that is relevant at the moment, right? And then the third use case is also for credential portability. As we see in the real world today, right? When you go open a bank account, for example, you have to present some type of physical ID to exchange for this new account. So that's similar online, right? Take that into the digital world. Well, how do we port and use different the same digital credential with the different business entity? So that is like credential exchange for a different type of account establishment. This is something that we will do a demo later that you will be able to see. So now that we know what verifiable credential is, let's take a look at the architecture. At the center of this diagram, you will see that we have three primary key player, right? The issuer who issue the digital credential, and the holder or the end user who own the digital credential, and then the verifier who is responsible for verifying the digital credential that the end user or the holder present in order to get access to certain things. And then at the bottom there, you see a trusted registry. It's also known as like a trust anchor, and it's whole all the information about the verifier or the issuer contain the public cryptography that allow the verifier to determine whether they will be able to trust certain type of credential that is issued by a certain issuer that exists in that trusted registry. Okay, so with that, we will go through. So with these different technology that we use to build the verifiable solution, we have, for example, the mobile wallet, the issuer, holder, or verifier, including the verifiable data registry that they're all based on a standard base, such as the W3C or the and then also we have the center there. You see the EID that is a European standard as well, right? These are built based on the credential model data model for a more secure, and it's also interoperable between different business entity as well. Okay, so up to now, we have been introducing the verifiable credential as an emerging technology. What do we offer, right? What does IBM Verify products offer for verifiable credential? With Verify products, you would be able to issue credential, verify credential, and also manage the credential through the mobile SDK that we provide, so that you can build your own cloud wallet or the mobile wallet, so that you can enable the end user to manage their own credential. And it's for different business, government entity, or individual user, right? And we built these based on the standard base, such as the mobile driver license, and we also leverage the W3C standard for verifiable credential data model. We also use the OpenID foundation for the issuing and verification. So I think the use case that we covered before is employee can even replace their physical badge with a digital badge now that enable you to, go prove who you are and also even go into the building, right? It's a way of digitize the onboard and offboarding. Okay. So let's visit the digital credential technology stack within Verify. At the application layer, we have the agency that are leveraged based on the different standard that we have, and also the cloud wallet, mobile wallet that is offered through the IBM Wallet SDK that customer can build, the mobile wallet based on that. The middle stack is a verifiable credential service. We do leverage different technology, standard technology, such as the ISO mobile driver license, the OpenID Foundation, and the W3C verifiable credential. For the trust exchange protocol, we do leverage the DIDCOM, which is the messaging protocol for agency to connect between each other so that they can issue or verify digital credential. And at the bottom layer, we have the Eco Trust system with the Hyperledger Indy out of the box by default. Verify product support the Indicio mainnet ledger. Okay, so with that said, what is the availability, which version, right? Do we have a verifiable credential available? We have the on-prem, for on-prem product, we have verifiable credential is GA in the version 11 of the IBM Verify Identity Access as an add-on. And for those of you who are new to this IVIA, it's the equivalent, or it's a rebranding of the ISVA or IBM Security Verify Access before this version. For SaaS, we have a closed beta that available for customer to request. I provide here the link of the digital credential if you want to know more information about our support of digital credential or verifiable credential, interchangeable. And so if you are interested in the closed version beta for the Verify SaaS for existing customer, you can contact support and they will get you enabled. We would love your feedback. And for those of you who are new and are interested in the to play with the verifiable credential, you can also first sign up for a trial. I provide the link here for you to create an account and create a trial tenant, and then you can contact IBM support to enable the service for you to try as well. With that said, we will come to, let's see. So in terms of capability, as I covered before, we provide the capability to issue credential, verify the credential for different type of key player, right? Issue, whether it's issuer, a verifier, or even the for the end user, then we provide the mobile SDK and wallet capability for you to develop for customer to develop the mobile SDK so that end user can store and manage their own credential. Right, with that said, we come to demo, yay. Demo is always fun, right? Shane did a good job earlier. So let's first, before we head to the recorded demo, let's go through the scenario here. At the bottom here, we have Jessica, which is a holder or an end user who would like to do business with the Big Blue Credit Union, which is, she want to open an account. Well, the Big Blue Credit Union is a modern company who support modern technology like digital credential, and its requirement is that you need two types of digital identity. One is to verify proof of employment, and the other one is some type of the government ID. In this case, we are using the DMV or the mobile driver license for it. So if you look at all these key players, Jessica is the holder or the end user. Big Blue Credit Union is responsible for both issuer, because it will be issuing a account for Jessica or a digital credential for Jessica, but it's also a verifier because it needs to verify the employment and the digital credential that Jessica will present, right? Also, the employer is the issuer, and the DMV is also the issuer. Each of these, for the purpose of this demo here, we have each of the key player will have different agency, and they are communicated through the DITCOM messaging protocol, as I mentioned earlier in the architecture chart. And we, as you can see, each of these agents are belong to a tenant, but it doesn't have to be that way as long as a business entity or the issuer, as long as their agent able to communicate using the DITCOM messaging protocol, then they can be able to interact with these different agents. Okay, with that, let's go into the demo itself. For the interest of time, because of the DMV and the employer are both issuer, if you see here on the left side, the mobile wallet, the employee employment credential for Jessica is already loaded. So through the demo, we will show you how Jessica will obtain the mobile driver license as the second type of credential and be able to use to obtain an account with Big Blue Credit Union. So with that, let me start playing. So here, since the credential for employment already loaded, you can see the different type of attribute that it have. So on the right side, it's different tab representing the representing different key players that we have. So with the Big Blue Credit Union here, as you can see, it is requiring two different type of credential. So Jessica would have to go and obtain that, right, before she can open. So now Jessica will go and log into the DMV to obtain the digital credential for her driver license. Okay, so In order to do so, Jessica would have to accept the request and approve the request to receive the driver license here, as you can see on the left hand side with the mobile wallet. Once you accept, you will see it show up the digital credential on her mobile wallet. So now, as you can see, she have 2. What happened next is that we can also show you how Jessica can use the digital credential to log back into the DMV. So you can notice the user experience here on the login flow with a little bit of friction, and you'll understand at later time when we provide some of the deployment where we will be talking about the login flow a little bit, right? So now Jessica is accepting that login request. She'll be able to log in. What happened next is that she will use the 2 digital credentials that she has and will open an account with the Big Blue Credit Union here. Okay, so now it's collecting the information. So you see a QR code here. This is because this is the first time Jessica is interacting with the Big Blue Credit Union. Therefore, she needs to create a connection with the credit union before she can start interact, right? So she will scan the QR code. Now let's see, accepting the request. Now next is it verify the employment and the mobile driver license in order to establish the account for her. As you can see here, this is based on a schema that she can share any of these information that is required by Big Blue Credit Union. So now Big Blue Credit Union, after verifying the information, able to issue an account to her. Jessica had the opportunity to accept and add it to her mobile wallet for future use. Now you see that she also have an account. Next step, we'll show you how Jessica can use the account, the digital credential that she just created to log in using an outbound like the QR code. And she will scan the QR code. This is a little bit different than the earlier login, where she used a QR code to log in, but the interaction is still going back to the digital credential that she have on the mobile wallet. And she would also follow the same experience to accept the login request. All right, so I believe that is the demo that we have. So now let's recap. Okay, so the deployment pattern here, as you can see earlier, the login flow where you use verifiable credential is a little bit of it have a little bit of friction there, right? Go through many clicks. So we would recommend that to use the digital credential just to establish, to create new account, or you do identity proofing. The second scenario would be for account recovery, where you have to prove your identity before you can recover your account, right? Another scenario is you use the verifiable credential to prove identity and gain eligibility to certain things. Like, for example, you can tap on, like when you go to the gym, you can, if they support like digital credential, you can tap and be able to share your information that they ask for and be able to get into the gym. Or even if you, let's say if you go to a bar and you need to prove your that you are at the drinking age before you can get a beer, for example, you just need to share the piece of information. You don't even need to share your birthday, right? You can share that, hey, you know, I'm old enough to get a beer. Then that's like little piece of information that you would be sharing with, that is relevant so that you can obtain certain access, right? So with that, let's get to the benefit for verifiable credential. It is protecting your from against identity theft or identity fraud, right? Because you own your own credential in your hand through the mobile wallet, for example, and therefore you want to share, and you are in control. End user is in control of when they use and what they share, right? And they only need to share minimal information about their personal data, right? Especially nowadays with the privacy is as important, and everybody care with not sharing too much information online, which vulnerable to attack, right? So by sharing minimal information, that would certainly help. And the other benefit of verifiable credential is that it's machine verifiable. So it's fast and it's instant. You don't need to, it can be used anytime. You don't need to wait for the bank to open in the morning in order to go do certain things, right? So it's faster and it's also secure. With that, let's recap on the use case. So as Shane covered earlier, the conditional MFA use case, right, is significantly reduce the user friction, and why it still maintain the security that is needed to combat the credential stuffing attack. So in the account recovery flow, it can be used MFA, 2FA to also help with account recovery. So that's for that use case. And then for passkeys use case, as you can, with the available of modern browser support for passkey, and even some of the newer native mobile application, it is a preferred first factor authentication because it helps with, it's a phishing resistant method, right? So it not I think Shane mentioned earlier that, you know, when you use passkey, any method is better, right? Any passkey method is more secure. Not all passkey are created equal. So if you can, for the higher assurance scenario, like for bank transaction and stuff, it would be good to use the credentials that are device bound, such as the hardware security, or you can use window hello, which are like attested passkey. But with that come with some challenging in account recovery, like what Shane mentioned earlier. If you lose like the your HS key, what do you do, right? So you either have to fall back to different the method that you've done before for account recovery, but hopefully the synchronized password will help with that situation. For verifiable credential, I think we went through that. It can be used for account sign up or account recovery, but or anything that are a little bit infrequent use of the login flow. Otherwise, it is not recommended for sign-in or authentication, just because it have a very higher friction for user. It's also some of the use case that we can use is for the reconfirm of the asserted attribute that are still current. So it's a re-verify of the verifiable credential attribute. Some other use case is related to non-account related presentation. Like I mentioned, some of the one of the scenario earlier is like you basically proof of A so that you can get a drink, for example, or you know you can go to the gym and also just like show your proof that you have a membership, for example, right? So those are really the scenario we have. That's a wrap. So thank you very much for joining us. I'm not sure if we have any questions in the chat or any question from the team. You can drop it in the chat and we can try to answer.
Yeah, guys, and thank you so much for that phenomenal presentation. That was a great session. There was a lot that I learned on my end, and we are at time. So if you guys do have any other questions, we have our office hours that are about to start in a few minutes. So please go hop onto the office hours chat, and I would love to see this discussion continue on there. But as another reminder, we do have our poll at the left bottom of our screen. Please take it and give your input as to how valuable this session was, and we're going to be utilizing that going forward. But otherwise then, thank you so much to our amazing team. This was a great session, and I hope to see you guys there at office hours. So thank you, guys.